So, (101). This is really 101. How do your customers cool their data center? Right? They may have air handlers on the white space. They may have them outside the white space in service bays, okay, that are around the perimeter of the data center. They may be using central package units, great big multi-100-ton units sitting on the roof, right, with ducting into the data center. But what they will typically be doing will be running their air conditioning the same way that you do at your house. Right? The thermostat is located in the environs of the return air filter openings, right? Going back to the AC. That's how it is in your house. Well, that's the same way most folks operate the cooling of their data centers. So we've got return air coming back to the air handler, and we have a 72-degree set point on the thermostat of those cooling units in the data center. So whenever that air is over 72 degrees, right, we're pumping water or coolant, refrigerant or something through the cooling coils and cooling that air before we send it back to the data center. Most computer room air handlers are rated at their cooling capacity based on an 18-degree temperature drop. Right? So if we're setting 72, well, that should actually be 54 degrees on the supply. But you're typically going to see this kind of relationship, 72 to 55, 72 to 54, that kind of difference. So what drives that behavior? Because we've got a lot of air in that data center that's significantly higher than 72 degrees. And we can supply air to our computers higher than 72. So why do we want to start cooling at 72 and drop it from there? Well, because we got all this mix-up of hot and cold air in the data center. In a standard hot aisle, cold aisle data center, the return air is coming back to our air handlers, and it's mixing with bypass waste cold air that's not getting to servers, and so you can see we've got significantly hot air out here. We got relatively cool air for supply. We've got all kind of mixed air here, and most folks have determined if we have that set point at 72 and we're delivering air under the floor at somewhere in the mid-50s, by the time all this mixing and recirculation and everything gets all done, that the servers are going to get air that's going to be somewhere between 64 and 80 degrees. Kind of, sort of. And the fact of the matter is, they're usually wrong, right? Because they're going to get air that's too cold to the data to some of the servers, and that's going to give them condensation problems, right? Because they'll be below dew point, and they'll actually make water inside those servers when the air's too cold, and they'll get hot spots as well. So some folks are living with this because they don't know how bad their rooms are. Some folks who are smart enough to go around and see how bad their rooms are, then they're going to drop that set point from 72 degrees to 71 degrees to 69. When you walk in a data center and the guy says, well, my set point is 69 degrees, you are looking a train wreck in the eyes. That's a disaster, right? So we got hot spots. And we got hot spots, yet at the same time, that return air that we're now going to spend $560,000 to cool, we could just ship that return air next door and cool a whole nother data center. Okay, let that sink in. We're spending $560,000 to cool air that's already cool enough to cool a whole nother data center. So when we change what we're doing from a standard hot aisle, cold aisle data center to hot air containment, one way or another, we're isolating the supply air from the return air. We have no hot spots any place in the data center. And we don't really give a rip about the temperature of the return air anymore. This paves the way to our value proposition to the customers. The first part of this is when we completely separate the supply air from the return air, the two most important things that the customer gets: no hot spots, and now he's able to change his thermostat from sticking that on the return air to putting it on the supply air.
So does that mean you have a greater differential between supply and return air?
Yes, it does.
Yeah. It does. Okay, so it doesn't give you the opportunity to raise the supply air temperature.
Yes, it does.
It does. So you can reduce the possibility of condensation.
Yeah, we'll do all those things. Okay. All right. We'll have a greater temperature difference going through the coils, but we'll also be able to raise the temperature of the air coming out of the coils. We'll do both of those things, and both of those have independent benefits, which we'll talk about. Okay?
So is there other air that's being recirculated into the contained air? Like, is there another intake? Or is it just the air that's being recirculated and controlled?
You'll have that's a non-101 question, all right? But no, that's okay. That's okay. We'll have the body of air will start with X, all right? And X is being cooled, X is taking heat out of the computers, X is being returned to the air handlers and being cooled. So we got X doing all this, right? However, we also have 5 CFM per square foot of air coming from someplace else, that's fresh, that's being pumped into that space. So you and I and the guy that lives there can actually go in and breathe, right? Because you need a certain amount of fresh air, right? And that's done in my lab here. I just tap into the building AC, which has enough of a fresh air component that I keep that coming in. In large data centers, they'll typically have separate air handlers that are responsible for their fresh air component. And it's usually about 5 CFM per square foot will be the amount of the X plus. Okay. She asked the question. Okay.